By the end of this module, you will get a basic understanding on the various ways of giving the control signals to the FC automation drive, analog and digital input and output control signals of the FC automation drive. In this module, we shall learn about the FC automation drive's inputs and outputs. Do you know how FC automation drive operates? That's simple. The drive operates by receiving control signals. The control signals gets into the drive in three possible ways. They are: 1. Input signals through the wiring connected to the drive control terminals. The drive control terminals are located below the LCP. 2. Serial communication from a serial bus. A serial communication protocol supplies commands and references to the drive, and reads status and data from the drive. The serial bus connects to the drive through RS485 serial port. For detailed informations, read General Specifications in FC Automation Drive Design Guide. 3. Through the LCP, on the front of the drive, when operating in local mode. These input include start, stop, reset, speed reference. The most commonly used are Profibus and DeviceNet, among the others. Now let's see the input signals to the FC automation drive. The FC automation drive can receive two types of remote input signal. They are digital signal, analog signal. The digital inputs are wired to the terminals 18, 19, 20 common, 27, 29, 32, and 33. The analog inputs are wired to the terminals 53, 54, and 55 common. Let's now have a look at the analog input signals of FC automation drive. Analog signals can be either voltage 0 to plus 10 volt DC, or current 0 to 20 mA, or 4 to 20 mA connected to terminals 53 and 54. Analog inputs can be varied via potentiometer connected to terminal 53 to control the speed up and down on the motor. The drive can be programmed to increase or decrease output in relation to the amount of current or voltage on the terminal 53 and 54. For example, a sensor or an external controller may supply a variable current or voltage. The drive output, in turn, regulates the speed of the motor connected to the drive in response to the analog signal. Next, let's have a look at the digital signals of the FC automation drive. The digital signals are simple binary, 0 or 1, which in effect act as switch. Digital signals are controlled by 0 to 24 volt DC signal. A voltage signal lower than 5 volt DC is said to be in logic 0 state, and a voltage signal higher than 10 volt DC is said to be in logic 1 state. Logic 0 is open, and logic 1 is close. Digital inputs to the drive are switched command, such as start, stop, reverse, coast, reset, and so on. The RS485 serial communication connector is wired to terminals 68 and 69. Terminal 61 is common, and may be used for terminating shields, only when the control cable is run between VLT drives, not between drives and other devices. Now let's see the output signals from the FC automation drive. The FC automation drive produces output signals that are carried through either the RS485 serial bus or terminal 42. Output terminals 42 operate in the same manner as the inputs. These terminals can be programmed for variable analog signal in 0 or 4 to 20 milliamps. Output analog signal generally indicate the drive frequency, current, torque, and so on to an external controller or system. Digital outputs can be control signals used to open or close damper or send a start command to auxiliary equipment. The additional terminals are Terminal 01, 02, 03 are form Relay 1 output. Terminals 04, 05, 06 are form Relay 2 output. Terminals 12 and 13 provide 24-volt DC voltage power, are often used to supply power to the digital input terminals 16 to 33. These additional terminals 16 to 33 must be supplied with power from either terminal 12 or 13 or from a customer's supplied external 24-volt DC power source. Improperly connected control wiring or interrupted wiring is a common service issue for a motor not operating or the drive not responding to a remote input. This ends of our stay in drive inputs and outputs.